Okay, YouTube, in our last video we introduced functions and their definition and how we represent them. In this video we're going to focus specifically on an equation representation of a function. So often we are going to represent functions using equations, usually involving two variables. And so just to kind of consider what that might look like, let's go ahead and start by looking at this equation that you see here, y equals x squared. And so one thing we want to be clear on is this. We say that this equation right here is the equation having y as a function of x. And so the reason we kind of refer to this as y being a function of x is because y is isolated, first of all. And we would need to know what the x value is in the first place in order to determine what the y value is. So this makes this kind of an input and output relationship here. So we're going to say that the independent variable, in this case, our independent variable is this variable right here. Independent variable is this one, but it is often really our input variable x. So we'd say input x, okay? And we would say that our dependent variable then would be what we get out of this function after we plug in a specific input variable. So this is dependent, but this is really kind of like our output y, okay? So when we talk about our dependent variable, it is often the output variable, whereas our independent variable is often the input variable. Now with respect to what we see up here, y is a function of x, where y is written in terms of x. We want to specifically state that the domain is the set of all values taken on by the independent variable. So because we say that domain is referring to the x variable, we're saying that the domain really is just the set of all numbers that x can actually possibly assume. And the range of the function is the set of all values that the y variable takes on with that given relationship. And so one thing to keep in mind is that the domain and range are not always all x values or all y values. So in order to represent y as a function of x, let's talk a little bit about what we want to do here. To represent or to determine if y is a function of x, let's go ahead and write a little description here. Determining if y is a function of x. The way we're going to do this really is this. We're going to rewrite with the y variable isolated. So get y by itself. And then the next question we're going to ask is this. Do all values of x for the function go to only one y or output? Okay, so we can go back and throw that in here. Let's go ahead and do that. Whoops, wrong button. Do all values of x, or in the domain, for the function go to only one y output? And so we're going to take a look at these two functions over here as a matter of fact and determine is y a function of x. And so the question really is, which of the equations represents y as a function of x, if any? Taking a look at letter A here, I noticed that the y variable is not by itself. So what we're going to do is we're just going to subtract this x squared to the other side here, and what we end up with instead is this. We get y equals 1 minus x squared, or we could even write this as y equals negative x squared plus 1. Either way you look at this, what I want you to notice is that if we were to make a table of values here, okay, and start filling in x and y values, for every value of x that I put in here, I'm going to square it and I'm going to take that away from 1. So that is to say, I'm only ever going to have one number for an answer, okay? So in this particular case, we could say that because y, getting it by itself in terms of x, when you plug in x only gives you one y value back, then we would say it is 1, 2, 1. And so therefore is a function. Y is a function of x. Okay. Now looking at this next example, you can see that to get y by itself, we're going to need to add x to both sides here. So we'll add x to both sides. We end up with this new equation, y squared equals 1 plus x. And then what we need to do to get y by itself here is take the square root of both sides. Now one thing to keep in mind this year, it's very important, is this. When you take the square root of something, okay, you took the square root of it, so you are responsible for putting a plus or minus in front. And so one thing that I want you to keep in mind here is this, and we could even, maybe give an example on a table here, but let's say what would be an easy number to plug in for x so that I could take the square root of this. And I could think of maybe 3. If we were to plug in 3 into this expression, we would get plus or minus 1 plus 3, which is really plus or minus the square root of 4, which is really plus or minus 2. So what you can see here is that if I were to extend this table, really 3 goes to positive 2, but 3 also goes to negative 2. And so because this is a 1 to 2 situation, or in other words, we could see that every input is going to go to 2 outputs here, then we could say that this is not y as a function of x. x. So to determine this, get y by itself and determine whether or not you would get one or two outputs as a result of your one input. Cheers.